All right, so for section 5.1, this will be our first section in Math 272, and we're going to talk about natural logs and the differentiation that goes along with natural logs. So let's, first before we start, let's look at a few things that are true with log properties. So when I talk about the natural log, I'm really just referring to, kind of how we undo exponentials. So the natural log of 1 is 0. The natural log of anything being multiplied inside the natural log, we can add those components to say the natural log of A plus the natural log of B. Then I have the power, well, we can't say the power rule, but so anyway, so we have the power. So if it's being raised to a power, then I can pull the power out front and multiply it by whatever's inside the natural log. And then if I have division, then I can say the natural log of A divided by B is equal to the natural log of A minus the natural log of B. All right. So now let's look at how this come about from a integration standpoint and a differentiation. Okay, so if you remember, we have that basic power rule for integration that says to integrate this, we would add 1 to the exponent and then divide by the new exponent. And then, of course, we tack on the C. Okay? So, as far as the natural log of x is equal to the integral from 1 to x of 1 over t dt. Okay, so what does this mean? It just means, and this is more of a fun fact, it can be derived using the limit definition of a derivative, but the derivative of the natural log, so if we have a function f of x that is equal to the natural log of x, then that just means that the derivative of the natural log is 1 over x. Okay, so the natural log has a derivative of 1 over x. Okay? It can also be said that if we have something like let's say that we have a function of u, that's the natural log. So if we have something other than x, so if we have x squared plus 2, or 5x squared or the cube plus 5, or something like that, then the derivative of it would be then 1 over whatever the u is, du dx. Okay, so we can multiply that by du dx. Okay, so I'll show you what I'm talking about in just a moment. So let's do an example here. My paper cooperates, right? Okay. So let's say that we have the derivative. We want to find the derivative of the natural log of 3x. Okay. Well, I am saying that u was 3x, but according to my differentiation based on the chain rule, right? This is all based on the chain rule. Take the derivative and then multiply by the chain. So then du dx would be 3. Okay. So I can just plug that in. So I know that I'm going to have 1 over u times du dx is 3, which is 3 over 3x, which is just 1 over x. Okay. So let's go ahead and do another one. So I want to find the derivative of the natural log of x squared plus 1. Okay. Well, I am finding the derivative of this component, so I need to pull out u and say, well, that's x squared plus 1. Find the derivative with respect to x to say, well, that's 2x. All right. So I have 1 over x squared plus 1 times 2x. Okay. So then I can just combine that to one term and say that is 2x over x squared plus 1. Okay. And let's go ahead and do one more, and let's introduce a product. So we want to find the derivative with respect to x of x squared times the natural log of x. Yeah. So then here would be a time that we could use the product rule, right? And so just in case on the product rule, if we have two functions or two terms, we say f times g prime plus f prime times g, right? You may also see the product rules with a's and b's or whatever, but we're gonna copy the first and then find the derivative of the second plus the derivative of the first of x squared times the second. Okay. All right, and so we do that. So we have x squared times natural log of x is 1 over x plus x squared, the derivative is 2x times the natural log of x. Okay. Now I can just clean this up a little bit and I can say, well, that's x squared over x plus 2x natural log of x. Okay. And something that I would like to see you do, just because of it being a Calc 2 course and having these capabilities, I do want you to try to simplify and factor things out. So the final answer here, I have an x in both, so I would really have x times 1 plus 2 natural log of x would be my final answer. Okay, draw some arrows here. Okay, so that would be the final answer for this using the product rule. Okay. All right, so now let's look at another few examples and why, maybe employing the natural log can help us. Okay, so let's say that we have a function. Well, if I can get this to. Okay, there we go. All right, so let's say that we have a function like this, where f of x is equal to the natural log. Nope, excuse me. Let's not use the natural log just yet. So let's say that we have f of x is equal to x times x squared plus 1 squared all over the square root of 2x cubed minus 1. Actually, yeah, let's just go ahead and say that this is the natural log. We'll do another example. So we'll say the natural log of this. Okay. So using all those power rules, or not power rules, but log rules that I had earlier, I can break this apart, right? I have division. So I can say, well, this is the natural log of x times x squared plus 1 squared minus the natural log of the square root of 2x cubed minus 1. Okay. And then just using those rules again, I can keep breaking it apart because I have multiplication. So I can say the natural log of x plus the natural log of x squared plus 1 squared minus the natural log of, and I'm going to rewrite this square root as a fractional exponent, and that would be 1/2. Yep. All right, and now I can take the derivative. Actually, not yet. I don't want to take the derivative because I can still break apart those powers and pull those powers out. So I'm going to say the natural log of x plus 2 times the natural log of x squared plus 1 minus 1/2 the natural log of 2x cubed minus 1. So now I have all these rules that I've used for exponents or for logs. And so now I can take the derivative because I've simplified it as far as I can and expanded as far as I can using the natural log. So now I'm going to take a derivative. Well, the derivative of natural log of x, that's just 1 over x. Then I have 2 times 1 over x squared plus 1 times the derivative of the inside, which is 2x, minus 1/2 1 over 2x cubed minus 1 times the derivative of the inside is 6x squared. Okay, and now I can just simplify. So I have 1 over x plus 4x over x squared plus 1 minus 1/2 times 6x squared, that's 3x squared over 2x cubed minus 1. Okay. Now for something like this, I'm not really concerned with seeing you simplify because I mean outside of just getting a common denominator, I'm not worried about what you simplifying this. Okay, so this would be good for me as a final answer. All right. So let's look at another example to where a natural log helps us simplify it and make it a little easier to deal with, and then then we can take a derivative. So let's say that we have y is equal to x minus 2 squared over x squared plus 1. Okay. Well, I could take the derivative of that using the quotient rule, but that's not an overly easy one to keep track of with the quotient rule. Okay. So what I'm going to do is I'm going to take the natural log of both sides. Okay. So when I do that, I have the natural log of y. Okay. And then just going ahead and breaking apart the division because I'm taking the natural log of this. So I have natural log and natural log. So I can say, well, this is the natural log of x minus 2 squared minus the natural log, and I'm going to go ahead and rewrite that square root as a fraction, x squared plus 1 to the 1/2 power. Okay. All right. So now using that or natural log of u is the derivative of the natural log of u is 1 over u times du dx. Yeah. So here I have the natural log of y. Well, when I take the derivative of that, I get 1 over y times the derivative of y, so y prime. Okay. Actually, I got ahead of myself here. Let's not take a derivative just yet because we can still break this apart. So let's say the natural log of y, 2 times the natural log of y is x minus 2. There we go. Let's go ahead and pull those powers out. X squared plus 1. Okay, so now I'm going to take the derivative. So I have 1 over y times y prime. All right. Here I have 2 over x minus 2 times the derivative of the inside. The derivative of x is just 1. Here I have 1/2 of, with 1 over, well, we go. Okay. I have 1 over 2x squared plus 1 times the derivative of the inside, which is 2x. Okay. So let's say I have 1 over y times y prime, which is equal to 2 over x minus 2 minus 2x over 2x squared plus 1. Okay. Well, my goal is to get y by itself. So I need to, or y prime by itself, because ultimately I'm trying to take the derivative of y. Okay. So to do that, I can multiply over by y since I'm dividing by y on the left. So I'll just multiply both sides by y. Okay. To say that y prime is now equal to y times all of this. Okay. However, I don't want things to just have terms of y's, but I do have a value for y, back to my original question. So I can just plug that in and say, well, y prime is equal to x minus 2 squared over x squared plus 1 times 2 over x minus 2 minus 2x over, or 2x squared plus 1. Now this could be simplified farther if needed. As far as for me, I am good with this this answer. But if WebAssign or something were to ask you to simplify this farther, I can show you how to do that and can give you some insight. But this is it for section 5.1. So I will, and then I'll have the video for 5.2 up for you to check out. If you do have any questions, please feel free to email me, and have a great rest of your day.